Today I'd like to help you start off learning about the quantum mechanical or the Schrodinger model of the atom. And it's a little bit more complicated than the Bohr model. The Bohr model, which you've seen on the board 100 times now, is we put electrons, those little, we always show them as these little red dot things. Those electrons with almost no mass, just a little bit of mass. And we put them in the first shell and then the second shell, third, fourth, fifth, and we fill them up as we go. Today we're going to start looking at a little bit more complicated model of the atom, which is probably a little bit more accurate and a little bit more helpful to us in more advanced applications in chemistry. But people notice that light was given off in kind of funny forms. If you look at a spectrum, you can see that some of these lines on the spectrum are very, very sharp, very well defined. Some of them are big and heavy duty. Some of these lines are kind of fuzzy, and some of them are found, like often, like every atom seems to have them. And so people were looking at these and they said, well, let's categorize these lines. And they called some of them sharp, and some of them were called principal, and some of them were called diffuse, cloudy, and some were called fundamental. But you don't really need to know sharp, principal, diffuse, or fundamental. But we'll focus on S, P, D, and F. And that, in just a moment, you'll probably be saying to yourself, well, why didn't these people use the letters A, B, C, and D? Which I suppose they could have. But instead they used S, P, D, and F. And this is why, in case you're interested. But you don't have to memorize the words. Just, you'll know what S, P, D, and F means after a while. Okay, so this fellow by the name of Erwin Schrodinger right there, in the early 1900s, he came up with the quantum mechanical model of the atom. And it had to do with this. People started to think that, electrons probably don't travel in little circles around and around and around and around the atom, but they're found in clouds, more like. So these little clouds are called orbitals, or 90% probability clouds. In other words, we know about 90% of the time where these electrons are found. So they're called clouds rather than, shells, first shell, second shell, third shell. So there are some terms that you'll need to understand. First thing is quantum numbers. Quantum numbers describe the location and properties of electrons. Where they're found. Are they close in or are they far out? Are they spinning one way or spinning another way? What's their relationship to other electrons also? So the first thing is called the PQN, or principal quantum number. PQN, it's almost the same thing as a shell. First shell, second, third, fourth, fifth, sixth, and seventh shells. Hopefully you know that atoms have up to 7 shells. You look at the periodic table and count how many lines across there are, and you'll see how many periods or how many shells there are. There's 7 maximum. This is sometimes given the letter N, like on your WKCE test. They might ask what a PQN is also known as. You'll say the letter N. Second thing is sublevel, or sublevel quantum numbers, which is sometimes given the letter L, and this refers to the shape of these locations where electrons are found. And these are the things that are called S's and P's and D's and F's, rather than A, B, C, and D's. So S, P, D, and F sublevels. Number 3, there's orientation or magnetic quantum numbers, which describe the direction, and we won't really discuss that at all in class. You can write it down if you wish, but you won't have to know that for a test. We won't really discuss that much. Then there's something called the spin quantum number. And the spin, sometimes people say, well, that electron is spinning this way, or maybe it's spinning that way, or at least it behaves like it is. And they call this clockwise, and they call this way counterclockwise. Sometimes people describe them as being plus 1/2 spin and minus 1/2 spin. And sometimes, and this is the one that we'll mostly use, people describe these electrons as going up or down. And I think of up as being clockwise, and I think of downward as being counterclockwise. It's just easier to draw arrows, straight arrows, than to draw little curlicues. Here's an electron, like that, spinning that way. Here's an electron spinning that way, the opposite direction. That's kind of confusing and messy. So it's easier to just draw up arrows and down arrows. And this one has an up spin, this one has a down spin, or you can think this one has a clockwise spin, that one has a counterclockwise spin. The point is they're opposite directions. And those things are called electrons. These are electrons. This is an electron with a positive or clockwise spin. This is an electron with a counterclockwise spin. And we want to know about how those electrons are spinning. Okay, so when you're talking about principal quantum numbers, those are like shells. First shell, second shell, third shell, fourth shell, fifth, sixth, and seventh shells. Okay, so these shells actually are subdivided into smaller units called sublevels. And the sublevels have those funny letters, S, P, D, and F. And it turns out that the sublevels are also subdivided into things called orbitals. And orbitals are going to be like little boxes that we look at. Take a quick look at what we just did. We said the Bohr model was awesome, but it's got some faults. It's not as accurate as we sometimes need it to be. So instead, often in more advanced chemistry, we use the quantum mechanical model of the atom, which was given, showed to us by Erwin Schrodinger a long time ago. And it's just a little bit more complicated than the Bohr model. PQNs, which are like the shell numbers, and sublevels, which are subdivisions of the PQNs. And they're called S's and P's and D's and F's. And then the sublevels are themselves subdivided into little tiny localities where electrons are put in there, and those are called spin quantum numbers. And electrons are said to have either a positive spin or a negative spin, or you can think of it as clockwise and counterclockwise. And that's today's lesson.